Hi everyone, I'm going to walk you through a quick tutorial of some of the main packages in the tidyverse, which is just a collection of packages in R to do data science. So this one package contains sort of a bunch of packages underneath, and we can use it to do kind of anything we want in the data science area. If you don't already have it installed, you can run this code chunk, or you can just type that down here and run it. And I won't go through each of these specifically, but you can look at the documentation and see all of the specifics of all these packages, but we're going to run through examples of each of these as well. So there's a package for plotting, a package for wrangling data, a package for working with strings, and all sorts of stuff. So kind of anything you need. It's kind of a toolbox of data science packages. And we can load it just with this, and it kind of tells us what it's loading. These are the packages we have above. And it's nice because we don't have to call library of 25 different packages. It just kind of imports everything. So dplyr is the first one we'll look at, and this is for wrangling data. So if you want to select rows, you want to select columns, you want to summarize data, anything of that nature. And first here, we're gonna use the mtcars dataset, which is a standard. It's just a dataset that's already loaded in R. So if you have R open, you have this dataset, and it's just from like the Motor Trend magazine. So it's just some data on cars, and we have these columns here that represent a measurement of each of these cars. So miles per gallon, cylinders, displacement, horsepower, things like that. And here we select these 4 columns. So say we just want to look at those 4, and we want rows, cylinders greater than 4, and horsepower greater than 100. We run this, and we see that the original data set has 32 rows, so we filtered out 11, and then we selected just these columns that we wanted. And you want to pay attention. So the data set, we're using this pipe operator, so we're sending it to this function, so to speak, and we use that throughout the tidyverse. You take data and you pipe it to something else. ggplot is responsible for anything plotting related, so any kind of visualizations you want to make. Again, the same sort of syntax where you take your data and you pipe it to ggplot, and then the aesthetic here is the sort of the mapping that will create our visualization under the hood. And then ggplot has a bunch of these different geoms. So you have geom hist, geom point, geom line, all sorts of different options. So we can run this, and it makes a nice plot, and there's tons and tons of customization options. You can change the color, the theme, the font, all sorts of things like that. But this basic syntax will get you going. Per is used to map functions to columns. So you don't want to sort of loop through columns with a for loop, or you don't want to write mean, and this is just like the mean function in R. You don't want to write that 8 or 10 or 20 times, whatever. So this is nice because it just maps everything for us. So we have this kind of syntax, and we run that. And if we view the mean values down here, we see that it gives us the mean values of each of those columns really nicely. Stringer is anything that you want to do with strings. So any sort of string manipulation with columns, or with just any kind of string vector at all. This can be like in the data itself, or it can be the columns and anything like that. So we're going to detect here if we have strings that contain a lowercase letter p. So we can look here, view this variable, and we see that it returns a sort of a Boolean vector of these columns and whether or not they have the lowercase letter p. And then we can run string replace all, which and these are just functions from the stringer package. So you almost don't need to know hardly anything about them. Just this argument is what we want to find, and this is what we want to replace it with. And when we run that and we look at this variable new names, we see that it's replaced all of the letters with uppercase values. For cats is for working with factors. So factor variables are in contrast to sort of just like doubles or integers. So we have cylinders here. So we have 4 cylinders, 6 cylinders, 8 cylinders. But we really want these to be factors because they sort of have a natural ordering, and we probably more want to compare them to other things as like these binned values rather than an integer value. And that can be a little bit tricky, but it's used commonly in, say, like regression or something. You don't want to interpret this as an integer value, you just want this as a factor. So we can run as.factor, and here we're actually using just base R syntax just to contrast it with how it might look from the dplyr version. So you can do a lot of this with base R syntax, but it's usually a little bit trickier. So we run this, and then we see here that we just created this data set, and we now have cylinder as a factor with 3 levels. So that's nice that it gave us, just does that pretty quickly. Tibble, you probably won't use this very often because a lot of things just get loaded in as Tibble, so you maybe wouldn't call this directly all that often, but we can actually look at the data set by itself, and we see that it's a data frame, so that's what DF stands for. And then, we run this, and then we see that it's now a Tibble. So it's just sort of, there's a lot of things like under the hood that are nice about it, just computational benefits and different things like that. So not a super common package that you might use directly, but it's used a lot under the hood. And then tidyr, this is kind of an example we'll run through quickly because it can be a little bit challenging, and it really just helps to look at it for a while. So let's make this data set called weather wide, and let's just look at this here. So we have measurements stored in what we would call wide, like a wide data frame. So we have like a location, and then for each day we have a measurement of something, say like temperature, precipitation, whatever. And we want to pivot that. We want to turn that into a long form. So we use this pivot longer and then sort of use these arguments that help us just like turn this data into a long data set. So it's really just easier to see how it works. So we run this, and then we see that it's sort of transformed this into now each location and temperature and day has like its own measurement, or each location and precipitation measurement and day has its own. And we do that because that's how we want to use the rest of the tidyverse. We want it to be in this so-called tidy format. readr, again, you maybe only use it once or twice in a data science project, but it just reads data in and can write data. So let's make sort of this little data set, and we can look at it here. So we have just some people and their occupations, and we don't have any CSVs. So looking in this directory, we don't have anything. So we'll just run this, and this is the reader package. So it creates this CSV for us, and then we should be able to read this in. And so it gives us some information about this thing that it read in. And let's see if we reload. We can see the data set that we created here, and then when we read that in, it gives us more information about sort of what it contains, and then we can just view it, and we see again that we've read it in, and it automatically created it as a tibble. So that was a really quick tour of some of the core packages in the tidyverse. Some more good resources. You can look at the documentation here and then find each specific package. And then R for Data Science is a great free book that you can look at here by some of the authors of the tidyverse.